Here we have a SAT math question. Okay, let's go to the information. There is a figure given over here. In the figure above, A and B are points on the circle C. If the area of the circle is 54 pi, what is the area of the sector formed by central angle ACB? So the central angle ACB is over here because it's ACB. So now we have to find the area of this sector formed by this central angle ACB. Okay, now let me write a formula to get area of a sector. Let me write it. So area of a sector is equal to, so theta divided by 360 degree times area of circle. Okay, let me write it. Okay, now this theta is the central angle of the sector. In this case, it's the angle ACB, that's over here. And we need area of circle to get area of a sector. Area of the circle is given in the question itself, that is 54 pi. We can plug in this 54 pi for this area of circle. But still we need the central angle theta, that is angle ACB over here. Okay, how do you have to get the angle ACB? So for that, let me consider the two sides of the triangle AC and BC. Actually, this AC is the radius of the circle and this BC is also the radius of the circle. Since both AC and BC represent the radius of circle, both of them must be equal in length. So clearly, this ACB is an isosceles triangle with the sides AC and BC are equal in length. So whenever two sides of a triangle are equal in length, the two interior angle measures which are opposite to the sides of equal length must be equal in measure. So let's consider the interior angle measure of the vertex A and interior angle measure of the vertex B. So both these interior angle measures are opposite to the sides of equal length. So the angle measure at vertex A and angle measure at vertex B must be equal because they are opposite to the sides of equal length. So this one has to be 50 degree. And then what must be the angle measure over here, that is ACB. So in a triangle, always the three interior angle measures will add up to 108 degree. So when I add these two angle measures, I'm getting 100 degree. Then this angle measure has to be 80 degree. So that these three interior angle measures will add up to 180 degree, which satisfies the angle sum property of a triangle. Okay, now I got the central angle that is of a sector ACB. So now we can plug in this 80 degree for theta over here. Let me do it, 80 degree over 360 degree times. So the area of circle is given, that is 54 pi. We can plug in 54 pi for area of circle. So now we have to simplify this one. So this 0 and 0 can be cancelled. And both 8 and 36 have the greatest common divisor 4. So 4 goes into, 4 goes into 8 2 times and 4 goes into 36 9 times. And this 9 and 54 have the greatest common divisor 9. So 9 goes into 9 1 times and 9 goes into 54 6 times. So now we have denominator 1 that can be ignored. Let's multiply the stuff in numerator. Here we have 2, here we have 6 pi. When I multiply 2 and 6 pi, I'm getting 12 pi. So the area of the sector formed by central angle ACB is 12 pi. We find 12 pi in option B. The correct answer choice for this question is option B.